as we finish up 6.1, one last thing they want us to kind of get into is finding a minimum sample size to estimate the population mean, which we use the symbol mu for that. So they're going to kind of build off of a formula. So given a confidence level and a margin of error, the minimum sample size n needed to estimate the population mean is going to be using this formula here. So some things they also note though, if n is not a whole number, then we need to round n up to the next whole number regardless. Always round up regardless. Also, when sigma is unknown, you can estimate using S. Remember, S stands for the sample standard deviation, provided you have a preliminary random sample of at least 30 members. So again, through the central limit theorem, to have this normal distribution, we have to have at least a sample of 30. So recall we had this margin of error formula. We could put this over 1, and we can solve for n by first cross multiplying. And this gives us then the E times the square root of n equals the z-score confidence number n times the standard deviation sigma. I then can divide each side by E to get the square root of n by itself. So that's going to now give us the square root of n equals this z-score times the standard deviation divided by the margin of error. So if I then square both sides, that's going to get rid of the square root symbol. That's going to give us then n equals then this z-score times the standard deviation divided by the margin of error squared. So we can actually use this formula if we know these three pieces of information, and we can actually determine a sample size. So let's put this to work and see if we can actually apply this formula. So the researcher in example 1 wants to estimate the mean number of hours spent on the required athletic activities by student athletes in the conference. How many student athletes must be included in the sample size to be 95% confident that the sample mean is within 0.5 hours of the population mean? So the z-score, the 95% kind of comes into there. So 95%, if we go back up there to our sample, hopefully I still have that stuff present. So in example 1, that was at 1.96. We also had the mean was 21.05. Let's see what else they gave us. They also gave us the standard deviation to be 2.3. So they gave us some things here. So as I said, the z-score with the confidence level of 95%, that's going to be associated with 1.96. The standard deviation was this 2.3. And the margin of error, that's where this 0.5 comes in. You have to be within 0.5 hours. That's the margin of error. That's going to be the 0.5. So let's make sure I got the right z-score there. So yeah, it looks like our numbers are all good. So if we put those into our formula, we should be able to determine what the sample size, the minimum sample size has to be. So I have 1.96 times 2.3 in the top divided by the 0.5, and that's all going to be squared. So let's see if we can actually figure out how to put that into the calculator. Again, you can do it one part at a time using order of operations, but if we want to use the full power of the calculator, let's see what we come up with here. So we have parenthesis, we have a fraction too, so I'm gonna use that alphabet, alpha F1, number 1. So I'm gonna have 1.96. I'm gonna have times then the 2.3. Then I'm gonna down, all right, divided by the 0.5. Come out of that, close my parenthesis, and then square it. And then if I hit enter, that'll give us this 81.2. Now remember, with rounding, n's got to be a whole number. And since it's 0.2, no matter what that is, it's always going to round up to the next whole number, which is now going to be 83. So the minimum sample size would have to be 83 to meet those conditions. 82, I should say. So we pick up on then n equals then 82, since we have to round up to the next whole number. Okay, so notice how, our sample size was only 40. To get this type of margin of error of 0.5, we're going to have to increase our sample size up to 82, because I think our margin of error was like 0.7, and that was with 40 student athletes. Okay, so that kind of gives you a little bit of an idea of how to define a minimum sample size.